Thanks, Joe. Thanks everyone for being here today. See some familiar names in the participants list. And if you live anywhere near where I live, thanks for being here and not outside enjoying this lovely spring weather that we're having. Um, Usually I talk about freshwater salinization in the winter because it's a topical topic. But this has been sort of a strange winter and maybe in the end good for low salt use. So my goal today is to talk about kind of just what like we as limnologists think and know about freshwater salinization. And this was a figure that I put together with Shelley Arnott a couple of years ago, thinking about how limnologists think about freshwater salinization. Um, and so everything from, where salt's coming from, how it's applied, where it's applied, and then how it actually gets from the application. So if we think about road salt from roads, if we think about, water softeners or agriculture, how it actually gets into our freshwater ecosystems. And then once it's there, what does it do to the actual ecosystem? So, what kind of changes are we experiencing from salt application? There's lots of questions about water storage. There's this legacy of just we've been salting for so long. What does that mean for the watershed? And then, of course, some of the impacts of salinization, thinking a lot about ecotoxicity, especially to aquatic organisms, but also to human health and protecting our drinking water sources that are certainly getting saltier in some locations. So this has been an interesting winter. As I said, it's been very warm, but we've also had some storms. And I live in Madison, Wisconsin, and we had this huge storm in January. Lots of snow, and it got really cold, and the city decided not to salt, and the road conditions were bad. But the city sort of lost its collective mind thinking about the road conditions. And so there was a number of letters to the editor, and these are a couple of the headlines. And what I'd like to say on the record is that, we as limnologists, but also, the city of Madison and, people who live here, they care about water quality because it affects people's lives. Especially when we start thinking about like how all this water is connecting to drinking water sources, right? Freshwater preservation is incredibly important for many reasons. There's sort of many ecosystem services that we all know come from having good water quality. And America's got a long history of using salt. This is data compiled from the United States Geological Survey. Commodity reports, they track imports, exports, productions of salt. And you can see over the last 40 years, the total consumption of salt has increased. And what's, maybe surprising, if, you don't think a lot about salt, is that over half of that salt use is for road de-icing. So of all the salt that we use as a country, half of it's going onto the roads, which means half of it is polluting the environment, right? It's not being reused in any way. So there's a nice infographic by Sujay Kushal's group to show this in this pie chart, which is, the US consumption of salt. The majority or the biggest use is for road de-icing. And then there's a lot used in the chemical industry. And everything else is pretty small, like agriculture and food processing. And these numbers are big. We're talking about millions of tons of salt. This is another nice infographic from Minnesota this year, where they looked at the salt use for road de-icing in Minnesota, which is about 500,000 tons, and imagined that in one giant pile, and it's about the same size as their NFL stadium. So this is where the Minnesota Vikings play. And it's just, it's an incredible mass of salt that we use every year that's going into the environment. And the salt use is trending up, but it's not necessarily trending up because we are using, applying more per area. It's really trending up because we just have more impervious surfaces that we want to de-ice. The population of the country is growing. There's lots of new developments. across the entire country. And so if we think about cities that use a lot of road salt, so I've just pulled up Madison and Milwaukee because it's where I live. You can see the urban development increasing, and a lot of those developments are relatively low density. So lots of roads, lots of parking lots, lots of impervious surfaces that people want to de-ice in the winter. And so that's really what's driving the upward trend. It's not necessarily that we're using more in the same area, it's just that we have more area that we're using it on. And really, when it comes to road salt as a pollutant, the thing to keep in mind is it's really driven by kind of road density and impervious surface. And so the more people you have, the more development you have, the more road salt you use. And it's a very, simple correlation between road salt use and, what ends up in the environment. So this is a map of Wisconsin, but a lot of states and provinces are similar, where we have some areas that are very dense and there's some areas that are very rural. And so you can see in Wisconsin, there's a couple counties in the south, that's where Madison and Milwaukee are located, that use the most road salt, and there's other areas that use very little. And again, this is just driven by kind of where there's people, there's roads. And I'm going to start showing numbers when it comes to salinization. And we usually track freshwater salinization by monitoring chloride. So that's the anion in salt. Sodium also shows similar trends, but chloride is a pretty conservative ion that it occurs in very low concentration naturally, and it doesn't get influenced by a lot of biological processes. So it's a pretty good indicator of pollution. And this is kind of an infographic that tries to explain that, the range of sort of freshwater to saltwater is quite large. Freshwater can have at times almost zero chloride. And the ocean, on like the one extreme, is the concentration of chloride is 19,400 milligrams per liter. And yet, when we define freshwater, it's really in this really narrow band where we're talking about chloride concentrations that, are less than 1,000 milligrams per liter. And I've thrown up some of these ecotoxicity thresholds that different countries use to define, at what concentrations you're going to see like biological problems. And the EPA's threshold is 230 milligrams per liter for sort of chronic effects, whereas Canada's is 120 milligrams per liter. And ecotoxicity thresholds are, they're defined based on lab experiments where you have organisms that are in tanks and you add salt and you see the effects. And these are very sort of broad brushes at what might be considered toxic. There's certainly organisms that are harmed at lower concentrations, and there's certainly organisms that are pretty tolerant to these levels of salt. And so, again, these are important for regulatory purposes, but are, a very broad brush when it comes to the actual ecotoxicity of salt in aquatic systems. Okay, so this is all to say, keep in mind that, 230 is the US cutoff, 120 is the Canadian cutoff for seeing some impacts. So these next two plots I've put up again are Wisconsin focused, but they're just taking sort of all of the data we have from the state, both from chloride concentrations in lakes and rivers, as well as sodium concentrations in public water systems. And again, what's very obvious is this connection between like where there's people, there's lots of road salt use, and that's where you see impacts to the aquatic environment. So again, we see, very high concentrations in lakes and rivers in our counties that use a lot of road salt. And the same thing goes for public water systems. And so there's, on one hand, you could look at these maps and say, look, there's lots of places that aren't affected. And that's completely true. There's lots of lakes and rivers that are not being affected by freshwater salinization. But if you are a lake or a river near roads and people, chances are you have elevated chloride and sodium concentrations. And that's very true as well with shallow groundwater wells. All this water is connected, and if we're putting salt into the environment, it's going to end up in our surface waters and in our shallow groundwater. So this isn't just a Wisconsin problem. These are the same maps for Michigan and Minnesota. And again, if you're familiar with the geography of these states, you can see that there's lots of elevated chloride concentrations around the Twin Cities, around Detroit. But if you get into northern Michigan or northern Minnesota, really not affected by human salt pollution, except at a very sort of local scale. So places that happen to be beside a large highway, for instance. So lots of spatial variability, but again, it really stands out kind of where there's urban infrastructure, we see these elevated chloride concentrations. So, that brings us to this question: if we have all this data, so kind of where are we headed when it comes to salinization of freshwaters? So I did this study a few years ago with a postdoc of mine and a student thinking about one watershed, and that watershed was the Lake Michigan watershed. So, a very large watershed, very large lake, thinking about how much salt is actually going into this lake. And this stemmed from the fact that Rob Mooney, who's listed here, had, for his PhD work, driven around Lake Michigan collecting samples from rivers. And on one of his trips collected, water from over 300 rivers looking at chloride. His data is on the left map, and on the right map is all the data available, all the publicly available data. And we tried to link chloride data to individual rivers and sort of what's going into Lake Michigan. Again, if you're familiar with the geography, we see high chloride concentrations in urban areas and very low concentrations in less populated areas. And one of the things that we were interested in is sort of like, where is this lake headed, right? We know what the concentration is now, we know what it used to be, and what can we expect from the future? And so we were able to use a model to look at the trajectory of chloride concentrations in Lake Michigan. And so the loaded now is about a teragram per year. So that's 1 million metric tons. And what's important to think about here is both sort of what the final concentration might be if things stay the same. Like if we just keep using the same amount of road salt, it's projected that Lake Michigan's probably going to hit an equilibrium around 20 to 30 milligrams per liter, which is fairly low in terms of chloride concentration. But keep in mind, this is a huge lake. It's one of the largest lakes in the world. And so it has this sort of dilution ability because its volume is so large. But the other thing to keep in mind is that this process is really slow. If you look at the x-axis, these are centuries. And so any changes we make to Lake Michigan are going to take a long time to sort of filter down into what's actual concentrations. And this is good and bad. It's good because it takes a long time to pollute Lake Michigan, but it's bad in that it takes a long time to fix problems. But again, this is an extreme lake, right? This is on one end of what we think about when we think about inland waters. And so from this, one of the questions that we had was, well, we can do this for Lake Michigan. Can we do this for all lakes? Where can we predict where lake salinity is headed? Everywhere. And so this was a paper I worked on with Chris Solomon, who led this paper, thinking about, well, what do we need to know to be able to predict chloride concentrations in lakes? And so this was a model that we made, basically showing that, and you can ignore the math here, but being able to quantify the concentration of chloride in a watershed based on the application rate of salts, what the road density is, what the size of the watershed is, and then how much of that is sort of removed and brought into a lake via precipitation, and the amount of salt that actually ends up in the lake versus ending up in, say, groundwater. And then the lake volume impacts that as well. And So this enables us to predict sort of the mass of chloride in the watershed and then the mass of chloride in the lake. And so we can play with these numbers, right? These type of models allow us to say like, well, if the road density was 0.01 lanes per meter squared, what does that mean for chloride concentration? And so we have this model where we could, if we could solve these parameters, we could then predict road salt concentration in a lake. And this is sort of a hypothetical model, right? These are parameters that we can adjust. But really what we wanted to do was use this in all lakes. And so what we were able to do is basically boil down these equations to just be able to predict equilibrium concentration of road salt in a lake. So not what it is today, but sort of what it will be in the future when it stops changing. So at some point, a lake's going to reach equilibrium with this watershed and sort of stay at a steady state. And so what would that concentration be? And to be able to answer that question, we just need to know three things: how much road salt is being applied, what the road density is, and how much runoff is coming from the watershed. And again, this is a steady state model, so we just assume that the amount of road salt we're applying now, we apply in the future, and the road density doesn't change. And so can we do this for all lakes? And the answer is yes, we can, because we have these amazing data sets now that provide information for all lakes in the United States, and then some data sets provide data for all lakes in the world. And so in one application, we looked at just the Great Lakes watershed, but we got watershed and lake data from Lagos. We got road salt data from a USGS gridded road salt data sets, and we got precipitation and evapotranspiration data from Hydro Atlas, which is a global data set. And that gives us those three values that we need. And so what we were able to do is take that information and basically predict equilibrium chloride concentration for all lakes. And this is the example from the Great Lakes watershed. So here we have 30,000 lakes on the US side of the Great Lakes watershed, and their equilibrium road salt concentration. And so you can see from the legend, they kind of vary from 0 milligrams per liter to over 500 in a few cases. And again, kind of localized to urban areas for the most part. And these are lake specific. So they're based on, the actual road density in that lake's watershed, which is pretty cool to be able to do that for 30,000 lakes. And this is really useful from both like a science perspective, but also a management perspective, where you might be interested in, a specific lake. Like you can go in and find that exact lake and be able to see what a model like this predicts. And again, this is just for road salt, so there could be other salt pollution sources in that watershed. But that's something that when you're working at a lake specific scale, you should be able to know about. And so if we just zoom in, again, you can kind of see specific lakes. The good news from this is that most lakes are not at very high concentrations. This is both a histogram of how many lakes pass these US and Canadian thresholds by state, again, in the Great Lakes watershed, and then sort of what percentage that is. And so really it's only a couple percent that surpass 120 milligrams per liter. So overall, like for lakes, it's a good thing. But certainly there are lots of individual lakes that are sort of at really high risk of high salt concentrations. And we can also do this for the entire country. So this is based on kind of a road salt use. And so there's some state boundary lines here, which obviously come into play. But yes, a pretty noticeable effect of sort of where road salt is used in the country. And nationally, you can also pull out sort of state by state, how many lakes are affected, what percent is affected. And again, that overall percent is quite low, which is good. That said, even if a lake stabilizes below these EPA and Canadian thresholds for toxicity. There's many reasons to be critical of these thresholds based on how they're made. And there's lots of researchers who are, organismal biologists who study ecotoxicity and have shown, really acute effects at concentrations below these for everything ranging from, freshwater mussels to zooplankton. And so it is, these are in some cases probably too high. But yes, this model is helpful in that it helps us know where lakes are headed, and then actually allows us to kind of zoom in on individual lakes. So a question from this that you might be asking is, well, this is just a model. You took real data, but you did it for all lakes. But can we actually fit this model to observed chloride data from an actual lake? So in Madison, we have 3 urban lakes, and we have long-term data from them for chloride. So you can see here from Lake Wingram, Lake Monona, and Lake Mendota in Madison, increasing chloride concentrations over the last 80 years. And so if we actually take that data, and I'm going to take it from Lake Wingram, we can fit this model and say, we know the watershed area, we know the road density, we know the lake volume. We can come up with a pretty good average for runoff, which is precipitation minus evapotranspiration. And then we can, play with this salt yield parameter. But we can fit this model and then look at what might happen if we reduce road salt use. So in this case, the model right now is fit to a road salt use of 5 kilograms per lane meter per year, which is fully in metric, and apologize for those of you who think about road salt use in pounds per mile. But if you think about 300 pounds per lane mile being sort of an average application rate, that might be like something like 60 or 80 applications per winter, which is actually somewhat average in that on a really bad storm, road crews might be out, 10 times during a storm. And anyway, we can then play with sort of what it takes to reduce those concentrations. And here, if we reduce road salt use to 0, you can see that those concentrations come down pretty quickly, but still take, maybe a century to fully kind of hit sort of natural concentrations again. But we think that this is pretty good evidence that this model's kind of useful in actually thinking about fitting it to real data. So a lot of work that can be done here on individual lakes. Okay, so I mostly think about lakes as a researcher, but also am interested in rivers. So one question is sort of what do we know about rivers and freshwater salinization? So this is something that we've been thinking about in my lab recently, which is, lakes tend to show this sort of steady salinization, especially when you have long residence times. We see these sort of long-term increases, whereas rivers and streams can operate really differently. And there's been, lots of research at the watershed scale showing what we call kind of episodic salinization, where we have, these big pulses in the winter and spring, and then it goes back to sort of base flow concentrations in the summer. And so a grad student of mine, Lindsay Platt, has been working on this for her thesis work, thinking about, can we take kind of what we know from USGS gauge data, so looking at specific conductance data from USGS gauges, to be able to better understand kind of patterns and trends in river salinization. And the USGS gauge network is amazing. It's, the USGS operates 10,000 gauges across the country, but a small percentage of those have long-term conductivity data. So actually that gauge data gets whittled down pretty quickly. So if we cherry pick some nice USGS gauge data, this is a stream in Massachusetts and a stream in Michigan, we can see this sort of episodic salinization pattern, where we have incredibly high concentrations in the winter, and then it sort of goes back to some sort of baseline in the summer, and then in December we start seeing these peaks again. And so Lindsay and I have been referring to this as sort of this road cell signature. We see this these really high winter concentrations, and you can imagine if you're an organism living in this river, this is sort of a harsh reality to be faced with, where you're basically dealing with like these pulses of brackish water for 3 months of the year, and it's a very different sort of habitat than if you're in a lake where those pulses are sort of diluted such that it's really much smaller variability, and is probably, if you think about sort of evolution of organisms over time, a very different pressure for natural selection on what can survive in these two different types of environments. So the question Lindsay's looking at is really thinking about like what's happening with these pulses, like how many sites experience these winter pulses versus what's actually happening in summer. Can these base flow concentrations tell us something about salinization? And so this is work that she's been digging into, thinking about, well, if all water is connected such that salt is polluting shallow groundwater, and that's really what's feeding base flow in these rivers, do we see salinization trends in these base flows concentrations? So this is an example of just pulling out summer data over time, and seeing kind of increases at some sites in these base flow conditions. And so she's been categorizing these different gauge sites as either having kind of episodic salinization in the winter, these base flow increases, maybe both, maybe a river's experiencing both, or neither. And then trying to understand the drivers of what is causing a river to be in one of those four groups. And so she's been really looking at landscape and river characteristics that drive that grouping, such that finding interesting ways that kind of groundwater characteristics shape how a river is experiencing salinization. And so this kind of goes back to that Lake Michigan study I showed at the beginning, thinking about just river characteristics. And these are seasonal bar charts from different watersheds that feed into Lake Michigan. So there's a little map on the right beside, and on the left are six box and whisker plots from 6 different tributaries that are very urban, so lots of road salt use, but on the smaller side. And you can see these kind of high concentrations in winter, decreasing in summer, and then increasing again in December. So this sort of episodic salinization trend, versus a couple large rivers on the right, the St. Joe and the Grand, which are 15% urban land cover, get a lot of salt use because it's a large watershed. But they're such big watersheds that they really don't see these kind of large winter spikes, at least near their outlets. However, you do see kind of the highest chloride concentrations later in the year. And so certainly this is sort of empirical evidence of the fact that for rivers, it's really all about size and groundwater inputs and what's happening in terms of the connection between groundwater and surface water. And again, this groundwater question is important, not just for thinking about rivers and that habitat, but also for deeper groundwater stores and drinking water. And this goes back to, that letter to the editor at the beginning saying, like, we're prioritizing water quality over people's lives. Well, it's like, we need water to live, and all of these things are connected. And so, Madison's not alone in seeing increasing salinity in their drinking water. It's all too common an occurrence, especially in private wells that just happen to be near roads that are heavily salted. So this work that we're doing is on kind of a large scale, but it certainly is supported by smaller studies, sort of more watershed specific studies. And this isn't my work, but I think it's something that's interesting to share. This is a paper that came out from a USGS group that's been sort of intensely studying the Delaware, the upper Delaware River basin. And they have found, a lot of kind of similar things that I've been talking about, which is seeing these long-term increases in conductivity, mostly during low flow. So seeing these base flow increases, but you get these really kind of frequent high conductivity events during winter high flows, often exceeding the EPA's chronic aquatic life thresholds. Also evidence for this sort of legacy salt in the catchment. So this idea that we've been salting for years and there's lots of salt that's stored in the watershed. So when is that going to finally reach the river? And then that you get these winter storm events that are really contributing these large pulses to the river itself. And here, this is an interesting study because it's sort of latitudinally you get kind of bigger rivers, but also more people. And so see this sort of latitudinal change in both concentration and then when you see the biggest changes. So this is a paper by Rumsey et al., which I encourage you to read if you have time. So to wrap this up, there's been a really good understanding in the field of the link between road salt and freshwater salinization. There's been a lot of papers on it in the last decade. This has been really helped by large public data sets that are able to be mined at a scale that really shows that this is pretty ubiquitous. And then it also enables us to link it to large scale drivers. So we have a really sort of foundational understanding of how common it is, what the range and concentrations we're seeing are. That said, we still need more monitoring, especially when thinking about the legacy effects of salt use, and also monitoring rivers that might be at risk but are just sites that we haven't thought about monitoring for chloride. And then also monitoring in a way that allows us to answer questions about how chloride might interact with other chemical cycling, thinking about things like heavy metals or nutrients. There's been lots of lab work that's shown that there might be interactions with things like algal blooms. And so how do we monitor in a way that allows us to both answer questions about salinization, but also kind of other issues when it comes to water quality. And then, I've been lucky enough to have, really great support locally and at the state level, thinking about reducing salt use. And, people are interested in it from both an environmental perspective, but also an economic perspective. I mean, road salt costs a lot to purchase, to put down, to fix when all of your infrastructure is rusted. And so there's a pretty concerted effort in some places to reduce salt use. And I think the next phase is really going to be about trying to understand how, if we implement changes, how that's actually linked to restoration. So how do we, best monitor for tracking improvements as we sort of go forward, thinking about, these changes in application practices. So I'm going to stop there. I do a lot of work with Wisconsin Saltwise, so if you're interested in just all things salt, I encourage you to check out their website. There's been some very exciting there bills at the state legislation level, thinking about liability protection and how legislation will help us in our effort to use less salt. So lots of interesting things going on in Wisconsin when it comes to salt use. And I'm hoping I have plenty of time to answer questions. So thank you.
Awesome. Thank you, Hilary. That's great. And I have a ton of questions. I found that really fascinating. but my job is to moderate the questions that folks in the audience have. So I see 4 questions from folks in the audience so far, and I'll give folks a chance, reminder. If you'd like to submit a question, go ahead and hover your mouse over the bottom to the Q&A function, and you can submit a question there, and then we'll try to answer it. So I'm going to take these more or less in the order that they came up. So the first one is that there was a map of projected equilibriums that you showed for the Great Lakes watersheds. And this is a kind of a methods question. There were some assumptions in your methods. One, that road density isn't going to increase dramatically due to development pressures. And 2, that runoff isn't going to change due to climate change. So do you have any resources for folks that want to look into the future, how they might kind of tweak those estimates that your research created?
Yeah, so what you said is true. So it's an equilibrium model based on today's data. And something like runoff is really challenging because it certainly has a huge impact on the variability that we see, especially in smaller lakes. And so, yeah, we're kind of lumping this into like one general runoff term. But those maps were made from a paper that's published by Chris Solomon in Limnology and Oceanography Letters. And all of the code and all the code and data for that paper are available online. So if anyone is a modeler and wants to take that code and run with it, certainly you can adapt it to be, I guess what I would say is like a dynamic model instead of a static model where you can change parameters through time. So yeah, I mean, I hope that I can make it a little bit more complex in the future. Just a matter of finding some time to play around with that.
Thanks. All right, the next question is about stratification. So at what chloride levels or concentrations is the turnover of lake water impacted? So are we seeing salinity gradients in lakes when you get heightened salinity levels?
Yeah, so that's a really great question. So one of the impacts of salinization is just on the physics of lakes, thinking about how as you increase salinity, you increase density. And so if you have kind of salty water flowing into a lake in the winter, its tendency would be to sort of plunge to the bottom and see this kind of salty pool at the bottom. And during spring mixing, especially, it takes more energy to flush out that salty bottom layer. And there's been a handful of papers that have looked at this sort of like site specifically and seen effects of turnover, at least like delayed mixing at concentrations anywhere from, a couple hundred to 400 milligrams per liter. So not all that high. And a postdoc of mine led a paper on this, also published in Limnology and Oceanography Letters by Robert Ladwig's the lead author. And he showed that in Lake Monona in Madison, that we do see delayed spring mixing from road salt inputs by a couple of weeks. After a couple of weeks, it's sort of that halocline has been chipped away at. And that density gradient was about like 1.3 kilograms per meter cube. So not a huge, again, not like a huge density gradient, but enough that it does impact mixing. In terms of the actual concentration, it's going to be lake specific because, if you're a deep, tiny lake, it's a lot harder to mix that than a kind of a shallow, wide lake. So the actual concentration to prevent mixing is going to vary based on the morphometry of the lake.
Yeah, that's fascinating. I did not know that it could delay mixing that much.
There's some lakes in Michigan that have just turned meromictic.
Yes, yeah. I should say I'm aware of some lakes like that where it's really high, but I didn't know that it could broadly affect it at those concentrations. Okay, next question is just sort of about access to some of the data you shared, which were really cool. So if we were interested in, what are the predicted salt concentrations for my lake, are there places where we can look to find those predictions from your models?
At this point, maybe just email me if you have a specific lake. I did make a Shiny app at some point, but I'm not sure what its current status is on existence.
Gotcha.
But maybe I should get that working again.
There's a lot of opportunities to
Yeah.
keep yourself busy, I think. Um, okay. What value do wetlands have in removing salt, and to what concentration do they just not function? Do they lose their ability to absorb and retain that salt?
Yeah, that's a good question. I mean, I I can't answer the second half of that question in terms of, you know, at what point are they saturated? Um, you know, salt is hard to remove. It's not like nutrients that actually get taken up and removed from the system. I mean, retention basins don't work for salt storage. They'll slow it down. And so they're good, wetlands and retention basins are really amazing for sort of slowing the pulses down. Um, but I don't think they're not going to have anywhere near the same effect on sort of actually removing it from the system that they do for nutrients. Um, and that's just a function of, you do have limited sort of storage capacity in the, I guess, sediments. And then plants themselves don't take up a lot of chloride. And so there hasn't, they're not, I don't think they're really thought of as being, they're going to modify the salt signal rather than really lower it, other than, we're also going to be polluting the wetland. So it's going to have bad impacts on the plants that live there and the organisms.
Thanks. All right. So the next question is, you kind of talked about two different types of water bodies, lakes, where the mental model is more a pool of water that's there more or less with some inflows and outflows, and then streams, which are a very linear system where there's flows through. And reservoirs are kind of a mix of those two types of systems. So is there any research on reservoirs, or do you have any kind of first principles thoughts on how the dynamics of salt concentrations might behave in reservoirs?
Yeah, so they're going to be sort of that mix where you don't have as long of residence time as some lakes. I mean, you'll just get water cycling through more quickly, and so it would tend to be more flashy. What I don't know a lot about, but what would be interesting is thinking about, reservoirs where you get kind of bottom water pulled out. And, if you're sort of preferentially pulling out saltier water because it sinks to the bottom. And so there's probably some interesting questions surrounding kind of reservoir management when it comes to salt impacts, but certainly something I don't know a lot about, but yeah, hopefully that answered part of that question.
Yeah, I think so. And kind of going along with that, so given that salt is dense and sinks into the hypolimnion, and you might have a pool of this salty water at the bottom of the lake, it might be unlikely to be flushed out. And so are there any recommendations you have for removing salt in the lake once there are high salt concentrations?
Yeah, I mean, if if it was a reservoir, you could maybe actually draw water from the bottom. There's, of the lakes I've heard of that have had that problem, there hasn't really been a management intervention necessarily to cycle it out. There's actually some interesting studies of lakes that kind of were salty from human pollution, that then were remediated, but in that remediation became aramictic because the top got fresh and the bottom stayed salty. And sort of just had this unintended consequence of kind of fixing the problem that then led to a lake that didn't mix. So yeah, some really interesting dynamics when it comes to salt stratification.
Yeah, interesting. Okay, we've got a ton of questions, so I'm going to try to keep up with them. This is like the rapid fire round.
Yeah,
So thank
I'll
you
be
for
quick.
keeping up with them. Okay, so it looked like some of the concentrations in streams, especially the ones in Massachusetts, but also in some of the lakes are above some of the toxicity thresholds that you showed. So are there documented kills of aquatic organisms attributed to spikes in salt or chronic
Yeah,
salt for that matter?
there's none that I know of. What's challenging is that a lot of these systems that are impacted by salt are impacted by other urban stressors. And so it'd be really hard for anyone, I think, to like if we had a freshwater mussel die off in Lake Mendota, be able to definitively say that was due to salt versus, you know, oxygen consumption or nutrient problems or invasive species or any of these other things that urban systems are just have a lot of different stressors. And so yeah, there isn't a documented case that I know of, because disentangling those impacts are just really challenging.
Yeah, it struck me in looking at some of the maps you showed that um, there might be some opportunity for natural experiments where like one county is salting a lot and then the
Mm-hmm.
county next door is not salting, or the state, some of the lines with really hard state political boundaries.
Yeah, totally.
So a question that I had was, you mentioned that the USGS, there was a USGS salt application layer. Can you say more about how that's created, or those data are
Yeah, I mean, I haven't looked at their metadata in a while, but it's certainly from state, county level data. What's nice about that data set is they really matched up to the country level consumption. Like, so at the beginning, when I said that the US, uses 23 million tons a year on the roads, if you added up all their grid cells, it adds up to like 23 million tons. Like, they've kind of broken it down in terms of knowing about road density, knowing about county and state level salt application rates. And so it's I think it's the most accurate estimate that we have for sure. And it's also annual for maybe a decade, so there's sort of some interannual variability in it as well.
so are those government agencies required through permits or through some sort of tracking system to submit that data, or for what
um
the data
I mean,
submitted?
the USGS tracks commodities. There's also there is sort of a, an organization that shares state level salt use data. And so that's publicly available and like a pretty good resource for getting values at the state level, which is sort of annual road salt use per state. And it's nice because it breaks it down as like road salt versus brine and other and what type of salts. But if you want to go sort of sub states, then you have to go usually to the state itself and get county level data.
Gotcha. I can imagine that is a very deep rabbit hole.
Yeah, there's a lot of states.
Yeah. Let's see. Sort of a broader question. So first, kudos to you on a great presentation. And then, have you come across any BMPs from other countries that have snow or ice conditions where they're dealing with this a lot, and they might be a little bit more, they might have different solutions than we do?
Yeah, I guess like in terms of official BMPs, I don't know off the top of my head. I certainly heard lots of anecdotes about how other countries deal with salt. I mean, I think the biggest difference between the United States and other countries that have sort of similar climates is just the kind of like litigation culture we have here in terms of slip and fall lawsuits. And most of the reason that people say they use a ton of salt is because they don't want to be sued. It's cheaper to put down salt than it is to deal with a lawsuit. And like that type of thing doesn't happen in a lot of countries. And so if you were to go to like Scandinavia or New Zealand, and that just you wouldn't be given that excuse as much, if at all. And so you see a lot more sort of application of things just like for traction, like sand, and there's either less or no expectation that you should have sort of clear pavement in the winter, and rather like we live in a wintry climate, and everything's slower in the winter, and that's just part of the culture. And so really it's a cultural expectation here that we have that a parking lot should be dry pavement for the entire year.
Yeah, interesting. Thanks. have a couple questions about sources, so I'm going to try to combine them. So the first is just, you've talked about road salt, but also, we see water softeners as another place where, at least at the residential level, a lot of salt is used. And then also salt can be airborne. Sounds like Illinois State GS did some research on this, but there might be others. So can you speak to these other sources, whether they're residential sources or airborne salts, and how those might change the results of the work that you've done?
Yeah, I mean, at a local scale, there's certainly other sources. At the national scale, like again, you saw that like road salt accounts for such a huge amount of salt that we put down in the environment. So, water softeners, if you're in a watershed where there's a city using water softeners, like those outputs from the wastewater treatment plant are quite large, and are actually easier to track because you have to have a variance if you're going above these, EPA limits. And so there is sort of a way to track that. In terms of yeah, there's lots of small sources that at a local scale can be important. And that's a matter of just like knowing your watershed really well and um, having a good sense of where that salt's coming from. And there's places in the country where there's salinization problems from mining and from industry and from definitely from drought, that have nothing to do with road salt. And so yeah, salinization is like a huge issue to freshwater resources, and my research is really just focused on kind of this region where road salt really is the dominant player.
We are number one in that. So here's another Joe-based question. You showed the conterminous US. If you were to put Alaska on that map, where would it? I would assume based on the low development, it's pretty low. But I guess I'm sort of curious, have you thought about Alaska and salt and application and maybe their cultural norms?
I haven't. Yeah, there's Alaska's included in some of these data sets and not included in others. So so it often gets unfortunately left out. Also as a state has a ton of freshwater resources. So the short answer is no, I don't. I mean the same thing can be said of Canada. It's like tons of road salt use in certain areas, lots of people in certain areas, lots of lakes. And it just like for the work that I've done, they haven't had quite as easy to access public data sets when it comes to some of the land, some of the like watershed level of data that I need. But yeah, I mean, there's there's a whole other country there that's doing the same thing we are.
Yeah. Okay. Let's see. We're gonna keep the rapid fire questions coming. So we've kind of touched on this already, but I'll ask it. It's got a different perspective. So what can local governments do to reduce the amount of salt that they're using? We talked about some norms and shifts around norms, but what are some other strategies that they can use?
Yeah, so governments are definitely the one place that can make the biggest change because they have like liability immunity when it comes to a lot of things. And so they have a lot more flexibility than like private entities do. And so one of the big sort of switches we're seeing is a switch to liquid application of brine versus rock salt. And that is, just basically you're just wetting the salt before you spray it on the roads, but it enables applicators to really reduce salt use because it's just a lot more effective to sort of spray on brine than it is to kind of pummel the road with rock salt that bounces off the road or you just put too much down. And so it's a lot more like specific application that just allows you to use a lot less salt. So that's a big kind of shift that we're seeing from local governments because they're often at a size where they can invest in like a brine maker. And you have to invest in the changing your truck from like rock salt to a liquid application, and it's those investments recoup their money very quickly because you save so much money on actual salt use. And so lots of counties that are investing in this see the return on investment within like a year. Like, I mean, really, really fast. And then, you know, aside from switching how they apply salt, it's really thinking about like where do you need to apply salt. And so, you know, there's municipalities like Madison who just salt their sort of main thoroughfares and their bus routes, and then they don't salt residential streets unless there's like an ice storm. Um, Whereas, you know, you can go to the city of Toronto and it's like they salt every single road, and like it's a huge city, and is that necessary? Or, you know, can you get by plowing small roads because, you know, you're driving really slowly anyway? And so really thinking about like what the expectation is from your tax base, which is, you know, also like it's politicians who are in charge of this. So like if people are mad that you're not salting the roads, you know, there's a tendency to salt the roads because, you know, you want to keep your city happy. And so there's definitely a lot of like politics that go into these decisions too, because it's, yeah, it's sort of expectations of like how cities are managed.
Thanks. I think that is a great spot for us to leave off today. It's 3 o'clock here in Michigan, 2 o'clock elsewhere. And I just want to again say thank you, Hilary, for taking the time to talk with us today and to share your knowledge. And I found it incredibly valuable myself. So thank you.
Yeah. Yeah. Thanks for inviting me, and thanks for all the great questions. Sorry I didn't get to them all.
So folks, if you're still with us, we're gonna send out a recording of the video if you'd like to rewatch it. And I'll also I'll CC Hilary when I share that recording. So if you had a follow-up question that you're dying to ask Hilary, feel free to shoot a question to her via email. Thank you all, and we'll see you next time. Take care.